Okay, for CER Part 2, okay, again, we're going to have our claim, evidence, and reasoning. Okay, so let's think about what the graph looked like. Okay, I had current here in amps and resistance here in ohms. Okay. All right, and then this graph looked like this, which is what's called an inverse. Okay, so in your evidence, you'll probably have this. Okay, again, you might show the simulation, describe what you did. Okay, you might show your data table in there as part of it, whatever. Okay, all right, so verbal model-wise, here we can see, right, that as the resistance increases, the current now is decreasing. Okay, right? When this number got bigger, this actually got smaller. All right. Okay, if you'd like to write your math model, let's go through it, and then you can write it in your reasoning. Don't explain it, though. I mean, sorry, in your evidence, okay? But now I have y equals k over x, which is what we call an inverse shape. Okay, my y is the current. Okay, my k probably was 12 if you did how I said to do. And then the x is the resistance. That's your x variable. Okay, so again, we want to look, and I know that constant k, right, is telling me something about the shape of this curve. All right, and the constant, because it's called a constant, it doesn't change. So I want to think what else in my experiment didn't change. Okay, and in this case, it was the fact that it was the battery, right? I set that at 12 volts to start with. Okay, so I can see that is my constant battery voltage. Okay, so if you want to write up here in your evidence, if you want to write your math model, you definitely can do that. Okay, just don't explain it. Okay, reasoning is where we'll start to explain all this stuff. Okay, all right, so reasoning, same thing. Some kind of an intro sentence. Don't just jump in and like throw in a math model or something. Give me some context. Okay, talk about your graph, right? Maybe your verbal model. Okay, and then probably give your math model. All right, so I have I equals 12 volts over R. Okay, and you can say how you got that, or you can just give the math model, is fine. All right, and then we want to kind of explain some of this, right? Basically, this constant K was the constant battery voltage, right? Because that's what you set it as. Okay, if yours didn't come out the same as your battery voltage, then you did something wrong. All right, so this one's a little easier to explain because there's no slope, there's no y-intercept, right? It just has this one constant K, and that's just the battery voltage. That's it. Okay, no y-intercept because it doesn't even cross the y-axis. All right, here again, we can see if I know that that represents voltage, here again, I'm seeing Ohm's law. Okay, right, which in this case, I'm basically saying when the resistance gets bigger, the current gets smaller. Okay, under same battery voltage. Okay, so what that means, right, is I have my battery, okay, and then say I have another battery, okay, and another circuit. If the resistance here, what is going on with this? Oh, boy. Okay, if the resistance is high here, that means this is a hard circuit to travel in. Right? This is a hard path. This is difficult. Okay? If this resistance is low, it means this is an easy path. This is an easy place to travel. Okay? So that's what the resistance is telling me, how hard or easy it is to travel in that circuit. Okay? If the battery's providing the same push, right, from the battery, okay, of course, in the more difficult circuit, that's going to be less charge flow, right? Because the battery only has so much push to give, and if the circuit's a very difficult place to go, that's going to be less charges are going to be able to flow. okay? As opposed to over here, when the resistance is low, this place is easy. It's easy to get around in this circuit. So when this battery pushes, the same as before, but the path is easier, that's going to make more charge flow. Okay? That's what I want you to explain in your reasoning. Okay? All right.